Welcome back to the channel, guys, with me Ibra, and in this video we're going to talk about a very useful community open source based software called Docker that you can use for free on your home labs, and hopefully I'm going to try and convince you to download and install it on your home lab. Now, it's important for me to remind you that you don't really need to put Docker on your home labs at all. It does add a level of complexity. It does take up resources away from your Raspberry Pi, from potentially doing other things that you want it to do, I don't know, such as a Pi-hole or a Plex server. But one of the main benefits that Docker does is that it really does simplify the way you deploy and package your home lab software and configure it too as well. And there's quite a lot to it. So if you're curious at all, if you want to know how you could use it, if you want to know how it could benefit you, even if you're just mildly curious and you're just maybe thinking about what it could potentially do for you, for your home lab, stay tuned, because that's exactly what we're going to talk about next. Now, Docker actually began life as a secondary product, an internal private product built by a company originally based in France, and their main product actually started failing, and then they realized that they should try and just chuck everything at the dartboard, as the old saying goes, and see what sticks. And it turns out that their actual secondary product that they've built was actually a product that later got released and rebranded as Docker. And then from a public competition, an individual based out of Indonesia won a public competition, which is where the Docker logo was famously acquired. And from the winner was the whale emblem created by Ricky Asamanis, a graphic designer from Indonesia. And that's kind of where a lot of people originally remember the Docker logo, which is basically the Docker whale. And it kind of gives you, much like the FedEx logo, it does really give you a good insight as to what Docker is about, which is this idea of a whale moving containers or a ship moving containers across the open seas. And the containers are individual pieces of software. And that's pretty much a very awesome logo, if you were to ask me for my opinion, in addition to it being a very cute logo, because the tech industry is filled with lots of weird logos that kind of go over your head. But anyway, my opinion aside, that's the Docker logo, and it was actually not their main product. The company was actually failing. So there are quite a few tutorials that I found that which you could follow. You've got the official Docker tutorial hosted on the main Docker Docs website. I've never used it. I paid for and used this Dome Train developer course aimed at developers, but I found that the way it was structured and the way the main terms were explained and the diagrams by Dan Clark, I thought they were brilliant, and I get no benefit for plugging paid for content. I hope I don't get into trouble for doing this, but my video, I get no benefits at all for supporting this content in my video. I'm just sharing with you what worked for me. I paid for this, I used it, I watched it, and that's where a lot of my knowledge came from. But you don't have to pay for official training on Docker. There's so much resources on YouTube. It's just a Google search away. And more importantly, you could just talk to Claude or Gemini, and they can actually get you started on your journey too. You could actually just use a simple prompt by asking Gemini, could you produce to me a basic tutorial, a step-by-step tutorial on understanding and learning the world of Docker. And honestly, that's it. A simple ChatGPT or Gemini subscription can actually teach you everything you need to know about Docker. So anyway, this is what I used. You don't have to use it. I'm not affiliated, neither do I get any kickbacks from it at all. I just wanted to put that disclaimer out there. You do have official tutorials from the people who make and produce and maintain Docker, and you do also have another one which I found which looks semi up to date, semi useful, but you guys can talk to me in the comments what you think. But I did pick this one because it's got a nice explanation as to what Docker is. Docker is an open source project that automates the deployment of software applications inside something called containers by providing an additional layer of abstraction and automation of the operating system itself. And there's a couple of key things to mention here. Is that originally, many years ago, you could actually use something called Docker containers for Windows. So basically you could have containers which are basically very slim pieces of software where a very slim baseline operating system has been provided for you that allows you to run your database, your API, or your web app, or whatever it may be. And Windows is kind of fallen out of favor. I don't know of anyone that actually uses it for personal or for enterprise needs at all. And pretty much the standard industry metric or use case is you'll use some blend of a Linux container. And the most common containers that you use in the world of Linux, or should we say images, containers are based on images. The most common one is something called Alpine. Alpine is a very thin, very basic image that you can actually get the Postgres database on. And this is kind of one of the benefits that is worthwhile selling to you. Once upon a time, developers would have to install full-blown images of SQL Server, all of the libraries, all the C++, all the dependencies, and it would bloat your local developer PC. It would bloat your server, your home lab with all this extra crap. That's just my personal opinion. But the difference is with Postgres, the difference with the official Postgres images and Docker images is that it's actually a shippable tiny piece of software that you can just pull, download and run and store privately, and almost like a black box in Docker. You can just hide it away and it just becomes something that Docker can maintain and manage for you using various Docker commands, which hopefully you can learn in one of these tutorials. Docker image is one of the commands you can use. There is a huge thing about your images have to be based on something, and if you pay attention closely, you can actually find Postgres version 17 based on Bookworm, which is I believe that's Debian 13. I think no, Debian 12, correct me if I'm wrong, and then Debian 13 is Trixie. So you can actually find images based on different Linux distributions of containers, and then what that does is then it will put a layer on top and it'll give you the software that you want. In this case, I actually want Postgres. But anyway, I'm probably explaining this probably badly, which is kind of why I'm hoping to refer you to one of these guys, one of these docs, probably do a better job of explaining it to you. It is not the job of this very brief video to give you the full overview. The whole point is there's a lot of material out there. Just pick something that works for you and just jump straight into it. Now, the next part of the overview of this video that we're going to jump straight into is the exact steps that I took to install Docker on my home lab. So tune in for that. My personal goal was I just wanted to have the ability to just SSH into my local Raspberry Pi server, and I just wanted to have the ability of just running Docker PS, something like that, and then it revealed to me the different containers or the actual image that I'm running and the containers that are running off it. And this is kind of one of the power of having a good SSH setup, which I've covered in previous videos, so please do go check that out. I didn't want to just log on directly to the box, pull up a terminal session. I want to be able to just query what I wanted to query directly from SSH, that remote shell access. And this is kind of what I'm going to try and show to you how I got this to work. So I've come to lean on Gemini quite a lot. I found it to be really useful when it comes to exploring rabbit holes and problems in the world of Linux when you're a complete novice like me. And do be critical when you talk to... you can pause the video, you can take these instructions directly from here. I can post this on the comments or the chat if anybody wants them, but you can pause the video and you can just look at the actual steps that I took. But it took me quite a lot of research, and the reason for that was because there are actually two blends of Docker official packages. There's one set of packages which are made by the Debian people, which has got the IO suffix on, and then the other one is the one that's available directly from the official maintainers of Docker, which is download.docker.com. That's where you can grab it. Linux, Debian, distribution, Trixie, and then stable. So you can pick one of these, and that's hopefully the commands that I'm going to show you. So there are two, but it took me a while to try and come to terms with which one do I actually want. And I basically settled on, give me the one that's maintained by the Docker people themselves. They themselves should know on the latest Debian distribution, the Debian build of Trixie, they should know exactly how, from a compatibility perspective, that if it works or not. So I decided I will stick with that. So if I go back to Gemini, so it took me a while to try and come to terms with where to get the package from, who should give the package to me, and what the steps should be. And in the end, as you can see here, there's quite a lot of scrolling, quite a lot of work I did to try to figure out, well, which rabbit hole should we go down. Anyway, so my personal recommendation is, for my needs, I stuck with the official one from download.docker.com. That's the one I want. Now, the first command that I got from Gemini was to clean up anything that was previously there. I don't want anything that I don't need that may be incompatible or may just be laying around taking up space. So the first thing Gemini gave me was a cleanup script, so that's what this is. Now the second bit, I actually grabbed it from a Reddit tutorial or a Reddit thread, and it's only 2 months old, so that gave me a lot of confidence that this is actually perfect. This is kind of what I need. So I took this and I got Gemini to verify and regurgitate it, and it played out exactly the way I thought. So these are the steps. So this is basically adding in the certificates you need to talk to Docker. So do your update, install the keyring, which gives you the access for the, and then is the thing that actually downloads the packages for you. And then, so if you keep following these commands, this one here is where it adds it as the sources list. The interesting thing about this is that it makes it pretty clear it's looking for bookworm, even though if you look at the actual source that it's actually querying, it's actually Linux Debian. I got a bit confused by that. I was kind of wondering, well, what's the issue there? Because it says there, Linux Debian. Bookworm does live under that folder, but I didn't actually want that. I actually wanted the Trixie one, but hey ho, I'll cross that bridge at some point. So these are the commands that I ran, and then the one that I wanted to expand on was that what do these individual components actually mean? So I got Claw to break the components out for you. So Docker CE, when you've got the C suffix on the end, that's the one that's actually maintained by the Docker people themselves, and it basically distinguishes itself from the Enterprise Edition. So that means Community Edition. There is a separate thing called the command line interface, which is how we run this stuff. So Docker image, stuff like that. So that's what provides access to that. So that's called Docker command line interface. It's actually split it out. It's separated from the engine so that the Docker maintainers can actually update the CLI independently. You've got the container runtime, and this actually revealed something to me that which I actually didn't know. Containerd is actually a standard container runtime that Docker uses under the hood, and it's also used by Kubernetes. I actually didn't know that. You've got the build engine, which is what you use to build your custom software. So you could be pulling the official package down that someone's published, like the actual image. So make sure you get your terminology right. When you're dealing with Docker, you're dealing with images. You pull images and then you create instances of those images called containers. Whereas if you're trying to build something locally, chances are you'll be needing this, the Docker BuildX plugin, to build a custom image locally. To build your stuff locally, you're going to be using something called Docker Compose. That provides access to something called multi-container applications, which is something that I do as my personal line of work, which is what this is. So this thing here, so this is a multi-container application that I built for a Vibe coding project. As you can see there, I'm using the Alpine Linux image for Nginx, and I think these are based on Alpine too. I can't remember. It's been a while since I set this up. And so when you've got multiple images that combine together to create one image overall that you pull and set up, Docker Compose gives you that ability to layer the functionality and give it quirky names. So proxy, UI, API, database. So you need Docker Compose plugin and the Docker BuildX plugin to make that possible. And then this functionality is exposed via Docker Compose, and then you've got the auto confirm flag. That's kind of a very quick breakdown as to what the different components are. Apologies if I'm rushing through it a little bit. I don't think there's anything else on there. I thought it was important that you know exactly what you're installing too. These are all official components that you need in order to run software like the way I've run it there. Secondly, set up the user. And then finally, when everything is officially set up and working, it doesn't actually take long, probably about 5 minutes. You should be able to do something like this: Docker run hello world, and you'll get a short-lived container, and that's it. This is a message that shows your installation is working correctly. You'll get a lot more output. You'll get a lot more. So if I do Docker, I think there's a command for Docker images. You can list all your images. So just do ls hello world. So if I do Docker image rm hello, this might be wrong, but how do you remove one or more images? I always get this wrong, but I think let's do help. -f force. Okay, so let's print that out again. Docker list is now gone. Now if we do Docker run, you should see this basically. Docker run hello world. It'll tell you can't find it locally, so it's going to go and pull it. So it's going to pull the image from somewhere. Where it should be pulling it from is the official Docker hosted registries. It'll tell you it's downloaded it, and then it'll add it to its local private registry, which is kind of what this error message is about. I can't find it locally, as you see there, and then it runs it. This kind of proves to you that your Docker setup is running locally perfectly, which is exactly what you want. And then once you actually have it running, like the way I've got it set up there, the next thing is you can actually start running really homebrew custom software that kind of gives you the power of, well, I can do all sorts of stuff with this. So I can show you a personal project that I've been working on. So if I show you a vibe coding project that I've been working on, this entire thing is actually running from Docker. This is the power of Docker. That once you go down the path of learning how to use Docker, you can actually start using chatbots and agents such as Cursor or Claude or whatever. So if I do Docker logs API like this, you should see some traffic coming in a minute. These logs are absolutely ugly. I haven't bothered to design them just yet, but anyway, ignore that. If I tell it to log in with my default admin account, if I click login, we should see some traffic. So the last timestamp was 2136. So 2136. You see 2137, and that kind of proves to you that this thing that we've accessed with this nice URL is actually hosted on my Raspberry Pi, and those are the logs to prove that it's actually working. And that's it. That is the power of Docker. Thanks for tuning in. I hope I've convinced you that it's totally worth putting Docker on there. Amongst all the many reasons that Docker gives you, the main reason it should give you to convince you that you can actually start installing your own stuff on there. So like Plex server, Image, that's another one, a Pi-hole server, if you're interested in home security and ad blocking, I believe it is. So Docker gives you unprecedented and kind of profound access to a huge world of open source software. And chances are, almost anything you install on your home lab, chances are the instructions you're going to find are going to be Docker images. So you will probably end up running into this brick wall at some point as to what is Docker and why do I need it, and what do I need to actually run it. I've given you an incredibly 15-minute overview, but Docker is one of those home lab kind of tools that you should slowly learn over a period of time, and nothing should discourage you from learning it, because it's the perfect tool for the home lab enthusiast, because it's the gift that keeps on giving. It's open source, you don't have to pay for it. Like Plex, you don't have to pay for the license for it at some point, and it's the key for your hosting dreams. Without it, you'll be putting databases and custom software that you've built, or maybe you've grabbed it from GitHub and then you've built it. But then if anything happens to your Raspberry Pi, if an upgrade on a, for example, when 4-key comes out or wherever, and you completely destroy your Raspberry Pi, chances are you're going to destroy, and something gets corrupted, chances are you're going to have to rebuild your Raspberry Pi again, and you lose all of the configuration and backups that you've set up for your Raspberry Pi because of the way you set it up. Docker remedies all of that, because Docker gives you the ability to set up volumes which control where your applications save or persist information to, such as config, logs, databases, etc. Where does the information actually live? You can actually configure that to live outside of your Raspberry Pi on an external drive. So Docker gives you amazing flexibility, and I highly recommend you check it out. So thanks for tuning in. I really appreciate it. See you in the next video. So one final comment before we cap off the video on installing Docker on your home lab. If you don't want, or if you don't like this command line user experience, if this does not work for you and this is a bit of a deal breaker, there is a user interface that you could install that makes managing Docker remotely a lot easier. Because if you scroll down in this little tutorial, you'll see that Portainer is actually a remote hosted website on Docker itself that you can connect to, that exposes Docker in a nice user interface, in a nice web app. So that is an alternative. That, look, if you don't want to use this experience, you can use this. And in this tutorial, it clearly tells you there, Docker run, and you can see there, he's actually pulling down Portainer. And that's the actual image he's pulling down. So someone's actually built this image. It's hosted somewhere, and probably on Docker Hub. And this guy has produced this really nice tutorial showing how you can pull it down and use it if this does not work for you. And that's Portainer. So that's useful. It's lightweight. It's complementary. It works with Docker itself as a natural extension, which is really cool. I like that. But a completely rival product stack is Podman. I've never used it. I can only go from what I use in my day job and for my personal home lab needs and uses. So I use Docker. Can't recommend it enough. And Docker's got an absolute plethora of docs and a massive legion of users that you can lean on the internet for when you need support. Stack Overflow, you could talk to chatbots like I do with Docker 2. I used to get stuck on whenever I had problems and I'd break down, I would just talk to Claude or Gemini when I was trying to get something sorted, especially when you're trying to design and build your own images, which is what these are, custom images I've designed. So the Marsh Point front end, API, these are actual Docker files that I have designed myself, and Docker Compose scripts them and pulls them all together. So there is an alternative. It is Podman. I don't know if they actually have a Linux user interface. It clearly says it does. I've never used it, but it's something that I'm hoping you guys can talk to me in the comments and tell me why you use it and what benefit it gives you. It clearly looks like a gorgeous UI. I'm not going to lie to you, but there's one massive benefit which I've got Claude to pull out for you why people use it. If you scroll down, you can see there Docker's, one of the main problems with Docker is that Docker requires root privileges when it runs, when you set it up. But Podman does not. Podman is rootless. And if anyone who's worth their salt as a developer or in the DevOps industries, they should tell you rootless access is the way to go. And as you can see there, no background daemon needed. Each container runs under a normal user account. What this basically means is that it can run on the most least amount of privileges possible. And that's really amazing. So as you can see there, security benefit, if a container gets compromised, the attacker only has users permissions, not the root. And that's kind of worrying. In this instance, I'm only dealing with my home personal lab network. This is not exposed in any way. I'm never going to set up a VPN so I could work remotely and access it. Those are just chances that I'm not willing to take. So this is just a private network for my own home lab needs, so that's just a risk that I'm willing to accept. But this is one amazing reason why you should consider Podman. But I've gone down the Docker CLI and Docker CE route because I know Docker well. But the difference is that you can still get around these massive limitations because you can actually design Docker files with restricted permissions. So if you ask Claude to give you an example, right, you can actually get around this problem by designing Docker files using, well, that's quite an old image. But when you actually build your images, you can actually set your images so that your serve stage, which is the part where the application starts serving the content to you, it actually runs on very limited permissions. This is a really bad example, but you can actually get Gemini or Claude to script out a Docker file for you. What this is a Docker file. You can actually get it to script it where the user that runs inside the container that serves the content to you actually has very little privileges. So there are ways around it. It's kind of best of both worlds. So anyway, talk to me in the comments. Let me know what you think. Thanks for tuning in. I really appreciate it. This video has clearly overrun. I didn't think there'll be over 20 minutes worth of material, but thank you. See you in the next video. Bye.